We need to be able to solve applied problems using the law of sines or the law of cosines, and the secret is to read your scenario and then to get a triangle drawn that illustrates that scenario. So let's do that. We have a man and a woman standing 3.5 miles apart. So let's label this 3.5, and there's the man and there's the woman, and they spot a hot air balloon at the same time. If the angle of elevation from the man to the balloon is 27, so let's go ahead and make the balloon up there and we'll label that as 27. And the angle of elevation from the woman to the balloon is 41, so that one's 41. Find the altitude of the balloon to the nearest foot. Well, altitude is how high the balloon is from the ground at a perpendicular distance, so we're wanting to find this. Well, that forms a right triangle. In fact, it forms two right triangles, the left one and the right one there. But I don't know any of the legs or the hypotenuse of the triangles. I only have got an angle inside there, and so that's not going to work until I get one of the sides of one of the right triangles. And then I could go to the right triangle and I could use right triangle trig to find out the altitude. So what I'm going to do is I'm going to look at the big triangle, the whole thing, and I'm going to use the law of sines to find one of the sides. And so in doing that, I have one of the sides, so I need the angle opposite that to have an angle side opposite at pair. And I don't have it, but I can get it because I've got 180 minus 27 minus 41. So that angle right there is going to be 112. So I'm going to set up a law of sines using that angle and the side opposite at pair, and I'm going to find the hypotenuse of this right triangle that's right here. So I'm going to set up 3.5 over the sine of 112, and then that's going to equal x over the sine of 27. So pretty straightforward law of sines. I'm going to multiply the sine 27 degrees over here, and then I'm going to get my calculator and I'm going to put in 3.5 sine 27 divided by sine 112, and I'm going to find out x is about 1.7. We'll carry it one more decimal place, 1. So I do know this side now, and I can look at the triangle that's a right triangle that's formed right there that has the altitude here h. This is 1.71 and this is 41 degrees. So I can just use right triangle trig and find the trig function that relates the angle I have with, it looks like opposite side and hypotenuse. So that's going to be the sine of 41 degrees equals opposite over hypotenuse. And then we can multiply the hypotenuse over here. Sorry, that's a little bit sloppy. And I can find then the altitude of the balloon. And it looks like I get 1.12 to 2 decimal places. Now, what it actually asked for was find the altitude of the balloon to the nearest foot. But these units are in miles because that's what I used here. The 3.5 was how many miles apart they were. So what I'm going to have to do to find the altitude to the nearest foot is I'm going to need to take these miles and convert it to feet. And there's 5,280 feet per mile. So I need to multiply that by 5,280, and it looks like I get 5,923 to the nearest foot. So 5,923 feet for the balloon.